Welcome to our first success criteria for the lesson, Opposites and Absolute Value. Our first goal is to find and then plot a rational number's opposite and its absolute value on the number line. Before we can do this, we need to be clear on all of the vocabulary embedded in that sentence. The first is rational numbers. So the root word of rational is ratio, and ratio is another way to say a fraction. So rational numbers are any number that can be written as a fraction of the form a over b, where a and b are the integers that we've been working with up to this point. So any counting number, any whole number, and any integer is going to also be a rational. The opposite of a rational number is the number that is the same distance from zero on the number line, but on the other side. So we can find the opposite by changing the sign of the original number or by multiplying the original number by a -1. So if we look at this example here, we have 4 is the opposite of -4. And we could read that as the opposite of, the opposite of -4 is going to be a +4. Likewise, -1/2 is the opposite of 1/2, because if I put the negative symbol in front of the half, I end up getting this -1/2. Lastly, we can then use that sign no matter what is behind it. So this -x can be read as the opposite of x. So if x is a positive number, this -x or opposite of x would represent a negative number. But if x is a negative number and you take its opposite, then what looks here to be like a negative would actually be representing a positive number. So that's kind of wonky, and we'll hit that later when we come into some of our problems. And then lastly, we have something that is called the absolute value. You've been working with this informally when you think about the number of counters that you have and you ignore the color of those counters, because it is also the same as the magnitude. So it's the distance between the number and zero, and it will always be positive. So we write it using these straight up and down bars, and we would read it as saying the absolute value of -3 is 3, because -3 is 3 units away from zero. The absolute value of 15.2 is just going to be 15.2, because this positive number, 15.2, is exactly 15.2 units away from zero. Once we understand the vocabulary, we are ready to apply it in the settings of problems. So our first one, number 1, says which point represents the opposite of 3. So we're going to find 3 on the number line, which we can see right here, and then we take its opposite, which will flip us all the way across 0 to the other side here, and we can see that S is the number that is the opposite of 3. On number 2, I want a point whose number has an absolute value of 4. That means from 0, I need to be 4 away from it in either direction. Well, if I look on this one, there's no labeled point at the 4, so I don't have a letter here. But if I come to the other side, we can see that Q is 4 away from 0, so Q is going to have an absolute value of 4. Number 3, I want the smallest absolute value. That is asking for the smallest distance from 0. And we can see here that t is the closest number we have to 0, so that t would be the one that is the smallest. Number 4, if I want the largest absolute value, I'm looking for the point that is the furthest away from 0. Whether it's on the left or right doesn't matter. And we can see here that going all the way to V takes 4.5 in length, and everything else takes less distance. So V is the one that has the largest absolute value. Number 5, I want to know which point represents a number that has an absolute value less than 3 and an opposite that is positive. So we look at where 0 is, and then we need to be able to go 3 to the right or 3 to the left. So any point in this purple area is going to be something that satisfies the condition that the absolute value is less than 3. The second condition is that I need the opposite of the number to be positive. So if the opposite is positive, that means the original has to be negative. So we look in the purple region for a labeled letter that is to the left of 0, and that turns out to be W. Lastly, number 6, we want to plot X, Y, and Z so that the distance to 0 from X is the same as the distance from 0 to Y, and the two numbers are opposites of each other. And then the third number, Z, is we add the distance of X to 0 to the distance of Y to 0. So we'll start first by thinking about X and Y have to be the same distance from 0. If I locate my 0, I can pick where it goes, I think. Then I'm just going to go the same distance to the left or right. I did an example that was 2 of these tick marks away, but you could have done 3 or 4 or 5 or just 1. It doesn't matter as long as the distance going from one to the other, Y to 0, as long as that distance is the same as X to 0. Once we've established that, then we got to make sure that when we plot our Z, that we take whichever negative numbers absolute value we had. So in my case, I put the Y on the left. So I will take this distance right here, and I will add it to the X's distance, and that will help me figure out where Z belongs. Number 7 is we want to now think about opposites and absolute value to complete the table. So sometimes I'll give you the point on the number line, sometimes I'll give you the absolute value of that point, and sometimes I'll give you the opposite. You have to work with any of the given information to generate everything else. So if you look at number 7, the first one, we see this labeled number 6. So the graphed number So if we look at this first one, the labeled point is this number right here, and it appears to be right in the middle of 0 and -6. So that graphed number is a -3. Once I know the graphed number is -3, I can take the distance of that number to 0, and it will be 3. And then I can find the opposite, which will flip it to the other side right here, and that would be a +3. If I look at the next one, the given information is that the absolute value is 7. Because the absolute value is 7, I could go either to the left or to the right to find the original graphed number. That means I have 2 options available, which is why I've put a -7 on and a +7. Once I graph the numbers, then I can find the absolute value, and it will be +7 for both of them. And then I can find the opposites, which will just flip across the 0 to the other side. On the next one, the graphed point appears to be about 1/4 away from -7. If I count, we would have -7, -8, -9, -10, -11. So we cut that up. It appears to be at -8, whose absolute value is 8, and whose opposite would be +8. Lastly, we are told the number is 12, or excuse me, we're told the opposite is -12. So that means the original graph number had to be +12, and the absolute value of that, or the distance of that number to 0, is going to be +12. Our last example for this success criteria is we want to know which of the following is not true about -6.7. Because that is a negative number, it's got that little negative in front of it, we know that A is going to be true. The opposite of that number then would have to be positive, so B is going to be false. C, the absolute value, is another way to say the distance from 0, and absolute value or distance is always positive, so that will be true. The third one says just a synonym for the absolute value. It's 6.7 units away from 0. So that is true. It just happens to be on the left side. And then the last one is using the notation for absolute value. So the absolute value of negative 6.7 is indeed 6.7.